Our next speaker is Rob Meyerson. You heard a little bit from him during the previous panel. You might have sat next to him at lunch or at least seen him around, and you're going to hear from him again. After a 10-year career at NASA's Johnson Space Center, where he worked on different aspects of the X-38 crew vehicle and the Space Shuttle programs, Rob Meyerson worked as the integration manager at Kistler Aerospace, where he was responsible for the landing and thermal protection systems of a privately funded two-stage reusable launch vehicle. 2 days ago, Rob Meyerson, as president of Blue Origin, celebrated a successful flight of Blue Origin's new Shepard vehicle. Did anyone watch that? Yeah, we watched it, yeah. Very exciting. We heard him this morning on the panel, and now we have them all to ourselves for a keynote, which I'm going to call Uniquely Rob. Why not? Let us welcome Rob Meyerson.
Thank you, Cameron. Let's see. I will. Go blue. That means two things to me, by the way. So, thank you, everyone. Appreciate the warm welcome. And on behalf of the entire team at Blue Origin, I'm delighted to welcome you here to NewSpace in Seattle this year. And at Blue Origin, we imagine a future in which millions of people are living and working amongst the stars. And that's not just NASA astronauts, but it's people like you and me. So that's what we're really striving toward. The new Shepard space vehicle, actually, I've got my lavalier here. So the new Shepard space vehicle is designed to carry 6 people beyond 100 kilometers, which is the internationally recognized line of space. And once there, our customers will be able to experience weightlessness and experience a view out of the most dramatic and large windows ever to fly in space. But New Shepard is really no ordinary rocket. Rockets have been flying to space for over 60 years, and they've been doing it the same way. They fly up, and when you're done with them, they land in the ocean, sadly, and they're just launched one time. And so after dropping their payloads in space, they just fall into the ocean, and this is what we've come to know and expect, and not anymore. So in November of last year, a new Shepard rocket flew to space. It was launched on its second mission. It rose smoothly, and observers that were at the site, including a few people that are in the crowd today, got to watch it until the engine cut off, and at about 200,000 feet. Once it was out of sight, the crew capsule separated from that booster, and both of those vehicles reached independent apogees above 100 kilometers above the ground. Minutes later, we were able to watch as that booster, powerless, came out of the sky on its 60-mile fall to Earth. And as it plunged towards the ground, and just as it appeared that it was most certainly going to crash into the desert floor, we saw a slight little flash down below as that engine, the BE-3 engine, ignited just as it had been designed. That engine fired up, and then within seconds, the descent rate was arrested. And by the engine thrust, and the rocket entered a slow and deliberate descent down to a small landing pad. Landing legs deploy, and it touches down, and it's something that is quite remarkable to see. After that first landing, and most of the landings after that, the rocket remains in this cloud of dust that's formed as the thrust kicks that dust on the pad and around it. So you can't really see that rocket for a second or so. And then the breeze scatters, and the dust is cleared up, and it reveals an upright rocket, which, just like that. That's the first view of New Shepard as it came back from its mission back in November. A perfect landing. But we're not done. Our customers that would be riding on that capsule were slowly descending in that capsule under its 3 parachutes. And once that capsule touched down, the reaction was as you would expect, euphoric, absolute craziness. And it's an incredible electric atmosphere that really only happens when you know you've done something monumental. So we're really, really proud to have been a part of that. So let's take a look at what that flight looked like in November. I'm going to bore you with a video or two. But there's an animated sequence in the middle. Don't be fooled. That's not real yet. But we put that animated sequence in the middle of this video to show you what our customers are going to experience in a few years when we start to sell tickets for these new Shepard rides. So, with that. So we thought it was a beautiful flight, and that rocket landing really was a sight to behold. The balancing a rocket engine on its engine plume is like balancing a pencil on your fingertip. It's really hard to do. And hitting the center of a small pad after free falling almost 60 miles is really an incredible feat as well. Since that flight, we've repeated that flight with that same vehicle a number of times, and as a matter of fact, we flew that rocket 3 times without even removing the engine before we attempted or conducted our flight on Sunday of last weekend. This last weekend's test upped the ante by pushing the envelope on our booster, doing a few things in our software to test out the aerodynamic characteristics of the vehicle. And then we also, on the capsule, we intentionally tailed one string of the 3 parachutes, so we only deployed 2 to make sure that redundant series is going to be okay for our astronauts someday. That concept worked on paper, but we wanted to test it, and Sunday's test, validated what we had designed. We also upped the ante in terms of outreach and sharing what we're doing with the rest of you by trying our hand at our first live webcast. And The webcast was narrated by two of our employees. One of them is here with us today, Ariana Cornell. She's a member of our business development team, but she she was the executive director of the Space Gen Advisory Council before going back to school and getting her MBA from Harvard. Jeff Huntington is a member of our guidance, navigation, and control team. He's been with Blue for 8 years, got his doctorate from MIT. So let me show the highlight video from that live webcast. This is on our website. The full webcast is available on our YouTube page, so they're both out there for you to watch if you didn't get a chance. If you were celebrating Father's Day in a different way on Sunday, we've made this available for you, so enjoy. Actually, I have to do this. So.
Welcome to all our viewers from around the globe to the first ever Blue Origin launch webcast. It's a beautiful day down here in Texas.
T-minus 10, 9, 8, 7, 6, 5, 4. Command engine start. 2, 1.
Rocket here from West Texas.
5,000 feet and climbing.
Coming up in a couple seconds here, we'll hit max Q. This is the point where aerodynamic stresses on the vehicle are at its max.
You don't see much of a plume with this engine, and that's because the propellants are liquid hydrogen and liquid oxygen. So it's actually a very clean burn.
It's the fourth flight of this new Shepard rocket.
We're now at Mach 3, 150,000 feet.
There we go. We've hit MECO. Main engine cutoff.
Right on target.
And there it is, separation. Jeff, at this point, if you were there in the crew capsule, you're going to start feeling that weightlessness. You're going to start to unbuckle. Do your somersaults.
Start doing somersaults. Look out that window. You can definitely see the blackness of space from there. 10,000 feet. That engine should be relighting soon. 5,000 feet. There's that engine relighting. 1,000 feet. Landing gear deployed. 5 miles per hour. Another picture-perfect landing for the new Shepard rocket booster. Let's cut over to the crew capsule because it's about to deploy its parachutes.
There we go. We've got the 2 drogue chutes which have deployed.
That means we are executing the primary mission of today's flight, which was to test the redundancy with our parachutes. There go the main parachutes. 1,000 feet off the ground. There's going to be that retro rocket system that fires just in the last second before touchdown. Keep in mind, it does kick up a lot of dust here in the West Texas desert. It looks like a hard landing, but really it just is a soft, pillowy touchdown at about 1 or 2 miles an hour. 100 feet.
Touchdown.
Wow.
Beautiful.
Picture perfect. That's exactly what we want.
Oh, that was magic. Well, on behalf of all the hardworking team at Blue Origin, thank you for joining us today, everybody on the internet, for our live broadcast of our new Shepard rocket flight. If you're interested in learning more and keeping up to date with our progress, please be sure to sign up on our website for email updates. And until next time, Gradatum for Rossiter.
Thank you. So later this year, we'll conduct a demonstration of our crew capsule escape system. That'll be an in-flight escape, demonstrating a key safety feature before we fly our first test astronauts in 2017. If all goes well with the test program, we should expect to begin flying astronauts, paying customers in 2018, and so we're excited about that. When Jeff Bezos founded Blue Origin, this momentous mission, landing a rocket back from space, was always envisioned as one step in this long journey to see an enduring human presence in space. I feel so fortunate that my path has led to this adventure. When that vision becomes reality, we will all look back on this blue planet, Earth, and consider it our origin, our blue origin, hence the name. So we at Blue Origin are dedicated to this vision, to making that vision a shared reality. There are many things that have to happen to turn that dream into a reality, but the first and most important is to dramatically lower costs and increase the safety of getting people and goods into space. That's the basic foundational building block of the new space economy, and it's what we at Blue Origin are dedicated to doing. While New Shepard makes it look easy, I can assure you that it's not. Landing a rocket after flying it tail first through a 60-mile free fall is a very, very challenging project, and there's some significant technical challenges to overcome. The first of them is propulsion, and it relates to engine thrust. So typically, the thrust on a rocket is sized for liftoff, setting your thrust-to-weight ratio around 1.3, something like that, and then landing the rocket with that same engine means that you've got to have roughly a quarter of that thrust to bring it down, a quarter or less. So on a multi-engine booster, you can shut off engines and land with fewer engines. On a single-engine booster like New Shepard, you need an engine that's got significant turn down, a significant throttle ability. And that's throttle ability that's well below the standard on most boost propulsion systems, which is about 70% of max thrust. So the BE-3 engine is a liquid oxygen, liquid hydrogen booster engine. It's the first of its kind to be developed in the last 15 or so years. It's also the first tap-off cycle engine that's ever flown into space, ever flown at all. It can continuously throttle from its top end of 110,000 pounds of thrust down to 20,000 pounds of thrust, enabling precise, controlled vertical landing, just like you saw in that last section of the video where it really literally looks like it's hanging on a string because the rocket is hovering. The engine's it must balance its duties of decelerating the booster while simultaneously keeping it upright and guiding it to that landing pad. And in doing it as the propellant levels are dramatically reducing down to zero. There's significant aerodynamic challenges as well. The rocket's got to be capable of flying in both directions, and it's got to do that with tail-first maneuvering ability and provide cross range to get you to that pad while also compensating for the high altitude winds. So our vehicle guidance and our control software has to manage constantly moving center of pressure and center of gravity during descent while it's performing this task. Individually, these are big challenges, but combined together, it's an even bigger challenge. And so, to our design team. So the reason we're doing New Shepard is, suborbital is not the end game here. We're doing New Shepard to practice. We as human beings, we're really get much better at things that we're able to practice. If you need surgery, you've probably heard this before, if you need surgery, you don't go to the surgeon that does that surgery 10 times a year. You go to the surgeon that does it 10 times a week, or 10 times a day even, with some surgeries. With New Shepard, it's a suborbital rocket, so we can fly it, dozens, if not hundreds of times in a reasonable time frame. Whereas with an orbital launch vehicle, your flight rates are going to be much lower. Typical orbital launch companies are flying a good year is about 10 to 12 launches a year, and that's a really successful year. So, what's next for us? Along with continued operations of our New Shepard system is the development of our orbital launch vehicle. It's a larger rocket that's going to take astronauts to low Earth orbit, as well as taking satellites up to orbital destinations. The first stage is going to be reusable, and it's going to land vertically in a very similar fashion to our New Shepard system. It'll have an upper stage that in the early stages will be expendable, and that'll carry satellites to LEO and GEO, and also our space vehicle up to orbit for our astronauts. We've taken over Launch Complex 36 at Cape Canaveral, and we'll be building our orbital launch pad there. And we're also building our manufacturing facility across the river near the Kennedy Space Center. We broke ground on that in May of this year, and we're going to be very excited to share more of the information as that building goes up. It is going to support the development of these very large stages and the refurbishment of those stages as well. So, Powering that vehicle will be a larger engine than the BE-3 that I mentioned earlier. We call it the BE-4. It burns liquefied natural gas, and it produces 550,000 pounds of thrust, so about 5 times larger than BE-3. We're well over halfway through the development program on the BE-4 with more than 180 stage combustion tests, like the one shown here on the chart, and 200 tests of our rotating machinery, what we call our power pack. We've also started testing the BE-4 preburner in our recently commissioned test cell down at our West Texas site, and we're developing the transient start sequence for the engine and making great progress on that. The series is preburner testing, then power pack testing, and then engine testing towards the end of this year. The BE-4 engine is the same engine that was selected by United Launch Alliance, the joint venture between Boeing and Lockheed Martin, to power their new Vulcan launch vehicle. Vulcan is going to debut later this decade, and it will carry national security and scientific payloads to low Earth orbit and beyond. We're also proud to be a member of the Orbital ATK Next Generation Launch Vehicle team with our BE-3U high energy upper stage. The BE-3U is a variant of the engine that's used for New Shepard with the larger expansion ratio nozzle, and that engine will be it's well suited for upper stage applications. So over time, Blue Origin has become that supplier of choice for America's premier launch companies, and it's a real testament to the investment that's been made in our engine line, both BE-3 and BE-4 over the last 10 years. So here's some parts for the BE-4. At Blue, we take advantage of the fact that we're coming of age in an era of high-performance computing and advanced manufacturing. A lot of new technologies have come into the field, and since I've been in Seattle. So we've made significant investments in bringing 3D printing, automation, and laser-wielding robots into our factory. And we can develop, we use these, we develop and maintain our critical processes in-house. While we are highly vertically integrated, we also rely on a strong network of partners and suppliers around the Seattle area and around the nation to add speed and flexibility to our development cycle, and we really rely on that team. We're all in on designing systems in a way that take full advantage of these new technologies. We don't rely on just printing the same kind of structure that you might have printed 10 years ago or built with conventional machining technologies. There's lots of advantages to additive manufacturing, and our design team is taking advantage of those. It's allowed us to rapidly accelerate our development pace, and as a matter of fact, on the new Shepard vehicle, we have over 400 additively manufactured parts on that vehicle that we're flying. Some of them are very simple, but they're still being printed as opposed to being conventionally manufactured. So this is the gaseous oxygen dome for the BE-4. This, all that 550,000 pounds of thrust goes through this part. We call it the GOX dome. We've manufactured this in 2 ways. We've manufactured it with traditional manufacturing using casting, and we've also manufactured a part using additive manufacturing. This part happens to be cast. It took nearly a year to manufacture, to procure. The cast version of this, which we already have one of those parts in-house and several more being built, took 3 months. So it gives you an idea of the kind of dramatic increases in productivity you can get with these new manufacturing technologies. We've been told this is one of the largest additive manufacturing parts ever built. Give you an idea of the size of that. And to kind of orient you, the gimbal for that engine mounts right on the top of that part near Nat's right hand. So let's see, coupling these new manufacturing technologies with our use of cloud-based computing for system optimization, computational analysis, and advanced modeling, such as applying computational fluid dynamics to the combustion problem on our propulsion systems. It really allows us to optimize the systems up front before we go and build. And then finally, pairing all that hardware with a hardware-rich test campaign allows us to anchor and refine all of our analytical models before we commit to full-scale development. So that means less risk in operations, more reliability. And doing this in our own facilities, like our large BE-4 test stand down in Texas, allows us to move significantly faster. In fact, we've done our benchmarking. We can move 4 to 5 times faster than in the traditional world where you're relying on large facilities that are operated by the government and others. We can conduct multiple tests in a day, and we have. And as a matter of fact, in the year 2015, we conducted over 550 engine tests at our West Texas site on our BE3 and our BE4 product lines. So just about any day of the week, you've got this going on, which is pretty exciting to witness. So, New Shepard is just the beginning. We have big plans, and to fulfill those plans, we need lots and lots of talented people. In addition to growth at our new facility down in Florida, we're looking to add hundreds of jobs across engineering and manufacturing and finance and business operations. Here's a picture of a couple of our interns on Sunday with me out in the desert. We have a great internship program, and a spot in our year-round internship program is really a highly sought-after position. We brought many of those interns with us today. The positions are highly sought after not only because we offer free housing and a competitive salary, but because we really make it, we give each intern a very personal experience. We pair them up with one of our experienced team members, and we give them a highly technical assignment that they can really grow and learn from. So it's something that we're really proud of, and proud of where interns can go. As a matter of fact, in the last few years, we have welcomed about 75% of our eligible interns, meaning they're graduating, back for full-time positions at Blue Origin, and many of them have taken us up on it. But the success of Blue Origin comes from pairing these fresh faces with rich industry experience. So when you look company-wide, a third of our staff have 20 or more years of experience working in companies around Seattle and around the industry, bringing that experience to bear with Blue Origin and collaboratively working together to develop the culture that we have. Our hiring bar is high, and you're going to have to want to work in an environment where everyone in the building is sort of at the top of their field and on the top of their game. We're committed to building not only rockets, but an awesome team. And if you're interested in joining us, take a look at our website or talk to one of the Blue Origin folks here at NewSpace, and I encourage you to do that. And if you want to get updates on all the cool work we're doing, a lot of the imagery that I showed today, not this last one, but they come out in our email updates, so you'll be the first to know when we send a message out about updates on BE4 or New Shepard or what our next test is. Go to our website, sign up for updates. We'll send you an email. You just need to confirm. We've done that before. And sign up, and we'll be happy to tell you what we're up to. And also, you'll be the first to hear about when we start to sell tickets, what the pricing is going to be, and all the details about that. At Blue Origin, our motto is Gradam Ferociter, and that means step by step ferociously. Stay tuned, because there are many more exciting steps to come. So thank you very much for your time and your attention. I don't know if there's time for questions. I'm happy to take them. So, Cameron?